Article 110.26 of the National Electrical Code, or NEC, mandates that electrical equipment be installed in a manner that provides adequate working space. This is so that qualified persons can safely perform maintenance and servicing. Section 380.14 of the NEC specifically addresses air conditioning and refrigerating equipment. It states that disconnects for equipment rated more than 30 amps shall be located within sight of the equipment and shall be readily accessible. The NEC does not define the terms within sight or readily accessible. However, the NEC commentary provides guidance on these terms. The commentary for Section 380.14 states that within sight from the equipment does not require that the disconnecting means be readily accessible. However, it requires the disconnecting means to be located so that it is visible to qualified persons servicing the equipment. Based on the NEC commentary, it is not definitively clear if working space is required in front of an alternating current, or AC, disconnect. However, it is clear that the disconnect must be visible to qualified persons servicing the equipment. If you are unsure if working space is required in front of an AC disconnect, it is prudent to err on the side of caution and provide working space. In essence, Section 110.26 of the NEC outlines the requirements for working space around electrical equipment. This section aims to ensure the safety of qualified electrical personnel while they are inspecting, maintaining, or repairing electrical equipment. The working space requirements are designed to provide enough room for electricians to perform their tasks safely and effectively, reducing the risk of electrical shock, arc flash, and other hazards. Here's a breakdown of the key aspects of Section 110.26. Firstly, depth of working space. The depth of the working space, or the distance from the front of the electrical equipment to the nearest obstruction, depends on the voltage to ground and the condition of the space opposite the equipment. There are three conditions to consider. Secondly, Condition 1. Condition 1 is where there is exposed live parts on one side and no live or grounded parts on the other side of the working space, or where exposed live parts are on both sides effectively guarded by suitable wood or other insulating materials. The minimum clear distance for Condition 1 varies based on voltage. For example, for voltages of 0 to 150 volts, the minimum clear distance is 3 feet. For voltages from 151 to 600 volts, the minimum clear distance is 3 feet. For voltages from 601 to 2500 volts, the minimum clear distance is 3 feet 6 inches. For voltages from 2501 to 9000 volts, the minimum clear distance is 4 feet. For voltages from 9001 to 25,000 volts, the minimum clear distance is 5 feet. For voltages from 25,001 to 75,000 volts, the minimum clear distance is 6 feet. For voltages from 75,001 to 150,000 volts, the minimum clear distance is 8 feet. Thirdly, Condition 2. Condition 2 is where there are exposed live parts on one side and grounded parts on the other side. The minimum clear distance for Condition 2 also varies based on voltage. For voltages of 0 to 150 volts, the minimum clear distance is 3 feet. For voltages from 151 to 600 volts, the minimum clear distance is 3 feet 6 inches. For voltages from 601 to 2500 volts, the minimum clear distance is 4 feet. For voltages from 2501 to 9000 volts, the minimum clear distance is 5 feet. For voltages from 9001 to 25,000 volts, the minimum clear distance is 6 feet. For voltages from 25,001 to 75,000 volts, the minimum clear distance is 8 feet. For voltages from 75,001 to 150,000 volts, the minimum clear distance is 10 feet. Fourthly, Condition 3. Condition 3 is where there are exposed live parts on both sides of the working space. The minimum clear distance for Condition 3 also varies based on voltage. For voltages of 0 to 150 volts, the minimum clear distance is 3 feet 6 inches. For voltages from 151 to 600 volts, the minimum clear distance is 4 feet. For voltages from 601 to 2500 volts, the minimum clear distance is 5 feet. For voltages from 2501 to 9000 volts, the minimum clear distance is 6 feet. For voltages from 9001 to 25,000 volts, the minimum clear distance is 8 feet. For voltages from 25,001 to 75,000 volts, the minimum clear distance is 10 feet. For voltages from 75,001 to 150,000 volts, the minimum clear distance is 12 feet. Fifthly, width of working space. The width of the working space should be at least 30 inches wide, or the width of the equipment, whichever is greater. This ensures that electricians have enough room to move around and perform their tasks safely. Sixthly, height of working space. The height of the working space should be at least 6 feet 6 inches, measured from the floor or platform. This provides adequate headroom for electricians to work comfortably. Seventhly, access and entrance to working space. Provisions must be made for safe access and entrance to the working space. This may include doors, hallways, or other means of egress that allow electricians to enter and exit the working space without obstruction. Eighthly, illumination. Adequate illumination is required in the working space to ensure that electricians can see clearly and perform their tasks safely. The NEC specifies minimum illumination levels for different types of electrical work. Ninthly, dedicated equipment space. The space equal to the width and depth of the equipment must be dedicated to the electrical equipment. No piping, ductwork, or other equipment should be installed in this space. Tenthly, foreign equipment. Foreign equipment is generally not allowed above or below electrical equipment. This helps prevent damage to the electrical equipment and ensures that electricians have unobstructed access to the equipment. 11thly, front working space. Generally, the working space in front of electrical equipment should be clear and unobstructed. This allows electricians to safely access the equipment and perform their tasks. 12thly, exceptions. There are some exceptions to the working space requirements, such as for certain types of equipment or installations. These exceptions are outlined in the NEC. It is important to note that Section 110.26 applies to all electrical equipment operating at 600 volts or less. For equipment operating at over 600 volts, additional requirements apply. Section 380.14 of the NEC deals with the specific requirements for disconnects for air conditioning and refrigerating equipment. This section is crucial for ensuring the safety of personnel who service and maintain such equipment. Here's a breakdown of the key aspects of Section 380.14. Firstly, location. The disconnect switch or circuit breaker must be located within sight from the air conditioning or refrigerating equipment. This means that the disconnect must be visible from the equipment it serves. This requirement ensures that the person working on the equipment can visually verify that the power is disconnected before beginning any work. Secondly, readily accessible. The disconnect must be readily accessible. This means that it must be easily reached without having to climb over or remove obstacles. The purpose of this requirement is to allow for quick and easy disconnection of power in case of an emergency or during maintenance. Thirdly, rating. The disconnect must have an ampere rating of at least 115% of the nameplate rated load current of the equipment. This ensures that the disconnect can safely handle the maximum current that the equipment is designed to draw. For example, if the nameplate on an air conditioner indicates a rated load current of 20 amps, the disconnect must be rated for at least 23 amps. Fourthly, type. The disconnect must be of a type suitable for use as service equipment. This means that it must be capable of safely interrupting the circuit under fault conditions. It also means that it must be listed and labeled for use as service equipment. Fifthly, multiple disconnects. If the air conditioning or refrigerating equipment has more than one power source, each power source must have its own disconnect. This ensures that all sources of power to the equipment can be safely disconnected. Sixthly, marking. The disconnect must be permanently marked to identify the equipment it serves. This helps prevent confusion and ensures that the correct disconnect is used for the equipment being serviced. Seventhly, height. The center of the grip of the operating handle of the disconnect must be no more than 6 feet 7 inches above the floor or working platform. This makes the disconnect accessible to personnel of different heights. Eighthly, exceptions. There are some exceptions to these requirements. For example, a cord and plug connected to air conditioner or refrigerator is not required to have a disconnect if the cord and plug are readily accessible. Similarly, a unit switch on the equipment itself can serve as the disconnect if it is lockable in the open position. Ninthly, enforcement. It is important to note that these requirements are enforced by local electrical inspectors. Failure to comply with these requirements can result in fines or other penalties. Tenthly, purpose. The purpose of Section 380.14 is to ensure the safety of personnel who service and maintain air conditioning and refrigerating equipment. By requiring disconnects that are located within sight and readily accessible, this section helps prevent electrical shock and other hazards. 11thly, local codes. It is also important to check with local electrical codes, as they may have additional requirements for disconnects for air conditioning and refrigerating equipment. These local codes may be more stringent than the NEC requirements. 12thly, best practices. Even if not explicitly required by the NEC or local codes, it is always a good practice to provide a disconnect for all air conditioning and refrigerating equipment. This makes it easier and safer to service and maintain the equipment. The term within sight is critical in electrical installations, particularly concerning disconnect switches for equipment like air conditioners. While the NEC doesn't offer a hard, numerical definition, the intent is clear. The disconnect switch must be visible from the equipment it serves. This ensures that the person working on the equipment can visually confirm that the power is off before beginning any maintenance or repairs. Let's break down what within sight practically means. Firstly, unobstructed view. There should be no obstructions blocking the line of sight between the disconnect and the equipment. Walls, partitions, or other equipment cannot impede the view. Secondly, reasonable distance. While not explicitly defined, the distance between the disconnect and the equipment should be reasonable enough that the disconnect is easily identifiable. A disconnect located across a large parking lot, for example, would not be considered within sight. Thirdly, clear visibility. The disconnect should be easily visible, even in varying lighting conditions. A disconnect hidden in a dark corner might not meet the within sight requirement. Fourthly, intent of safety. The primary goal of the within sight rule is safety. By being able to see the disconnect, a technician can visually verify that the power is off, reducing the risk of electrical shock. Fifthly, qualified personnel. The within sight requirement is typically interpreted with qualified electrical personnel in mind. These individuals are trained to recognize electrical equipment and understand the importance of proper lockout/tagout procedures. Sixthly, exceptions. Some exceptions may apply depending on local codes and specific equipment types. For example, a small, cord and plug connected appliance might not require a separate disconnect within sight. Seventhly, enforcement. Electrical inspectors have the final say in determining whether a disconnect meets the within sight requirement. Their interpretation may vary based on local conditions and code interpretations. Eighthly, documentation. To avoid disputes, it's always a good idea to document the location of the disconnect and its visibility from the equipment it serves. Photos or diagrams can be helpful in demonstrating compliance. Ninthly, readily accessible. The within sight requirement is often paired with the readily accessible requirement. This means that the disconnect must not only be visible but also easily reachable without having to climb over or remove obstacles. Tenthly, common sense. Ultimately, the interpretation of within sight comes down to common sense and good judgment. The goal is to ensure that the disconnect is located in a way that promotes safety and prevents accidents. 11thly, example. Consider an air conditioning unit located on the roof of a building. The disconnect switch should be located on the roof, near the unit, and easily visible from the unit. It should not be located on the ground floor or hidden behind other equipment. 12thly, local amendments. Be aware that local jurisdictions may have amendments to the NEC that further define or clarify the within sight requirement. It's always important to check with local authorities to ensure compliance. The term readily accessible as used in the NEC, means capable of being reached quickly for operation, renewal, or inspections without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, and so forth. Let's break down this definition to understand its key components. Firstly, capable of being reached quickly. This implies that the item in question, such as a disconnect switch or a circuit breaker, must be located in a place where it can be accessed without significant delay. Secondly, operation, renewal, or inspections. The accessibility must be provided for these three purposes. Operation refers to the normal use of the equipment. Renewal means replacing or repairing components. Inspections are for checking the equipment's condition and compliance with codes. Thirdly, without requiring to climb over. The definition explicitly prohibits requiring personnel to climb over obstacles to reach the equipment. This includes things like fences, sack materials, or other equipment. Fourthly, or remove obstacles. Similarly, personnel should not have to move or disassemble anything to gain access. This rules out situations where the equipment is behind a locked panel or buried under storage items. Fifthly, or to resort to portable ladders, and so forth. The use of portable ladders or similar devices is generally not considered readily accessible. The intent is that the equipment should be reachable from a normal standing position or a permanently installed platform. Sixthly, intent. The underlying intent of the readily accessible requirement is safety and convenience. It ensures that qualified personnel can quickly and easily operate, maintain, or inspect electrical equipment. Seventhly, height limitations. While not explicitly stated in the definition, there are often height limitations for readily accessible equipment. Typically, the operating handle of a disconnect switch should be no more than 6 feet 7 inches above the floor or working platform. Eighthly, dedicated space. The area around the equipment must be kept clear and unobstructed. This includes maintaining adequate working space as defined in Section 110.26 of the NEC. Ninthly, exceptions. There may be some exceptions to the readily accessible requirement depending on the specific application. For example, certain equipment may be allowed to be located in locked rooms or behind locked panels if access is controlled and only qualified personnel are authorized to enter. Tenthly, common sense. As with many NEC requirements, common sense plays a role in determining whether something is readily accessible. The goal is to ensure that the equipment is located in a way that promotes safety and efficiency. 11thly, example. A disconnect switch located behind a locked door in a storage room would not be considered readily accessible. Similarly, a circuit breaker panel located in a crawl space with limited headroom would also likely violate the readily accessible requirement. 12thly, local codes. Always check with local authorities to ensure compliance with any local amendments or interpretations of the readily accessible requirement. In summary, the NEC commentary serves as an interpretive guide to the National Electrical Code. It provides explanations, clarifications, and examples to help users understand and apply the code requirements correctly. Here's a more detailed look at the purpose, content, and use of the NEC commentary. Firstly, purpose. The primary purpose of the NEC commentary is to provide additional information and insights beyond the basic text of the NEC. It helps users understand the intent behind the code requirements and how they should be applied in various situations. Secondly, content. The commentary typically includes explanations of the code rules, examples of how the rules should be applied, and illustrations or diagrams to help clarify the requirements. It may also include historical context and discussions of the rationale behind certain code changes. Thirdly, organization. The commentary is usually organized to follow the same structure as the NEC itself. Each section of the NEC is typically followed by a corresponding commentary section that provides additional information. Fourthly, use. The commentary is intended to be used as a supplement to the NEC. It is not a substitute for the code itself. Users should always refer to the actual text of the NEC to determine the specific requirements that apply to their situation. Fifthly, authority. While the commentary is a valuable resource, it is important to remember that it is not part of the NEC itself. The NEC is the official code, and it is the document that is enforced by local authorities. The commentary is merely an interpretive guide. Sixthly, updates. The NEC and its commentary are updated every 3 years. It is important to use the most recent edition of both documents to ensure that you are following the current code requirements. Seventhly, training. Many organizations offer training courses on the NEC and its commentary. These courses can be a valuable way to learn how to use the code effectively. Eighthly, expert advice. If you have questions about the NEC or its commentary, it is always a good idea to consult with a qualified electrical professional. They can help you understand the code requirements and how they apply to your specific situation. Ninthly, examples. The commentary often includes examples of how to apply the code requirements in different scenarios. These examples can be very helpful in understanding the intent of the code and how it should be implemented. Tenthly, illustrations. The commentary may also include illustrations or diagrams to help clarify the code requirement. These visuals can be particularly helpful for understanding complex or technical concepts. 11thly, limitations. It is important to recognize the limitations of the commentary. It is not a substitute for the NEC itself, and it should not be used to justify deviations from the code. 12thly, code adoption. The NEC is adopted by many state and local jurisdictions. However, some jurisdictions may make amendments or modifications to the code. It is important to check with local authorities to determine which version of the NEC is in effect and whether there are any local amendments. The recommendation to err on the side of caution is a common and prudent approach in many situations, especially when dealing with safety, compliance, or uncertainty. In the context of electrical work and NEC requirements, this means taking the more conservative or stringent interpretation of the code, even if it's not explicitly required. Here's why and how to apply this recommendation. Firstly, safety. The primary reason to err on the side of caution is to prioritize safety. Electrical systems can be dangerous, and even a small mistake can have serious consequences. By taking the more conservative approach, you reduce the risk of accidents, injuries, and property damage. Secondly, compliance. Building codes and regulations can be complex and open to interpretation. If there's any ambiguity in the code, it's best to err on the side of caution to ensure that you're in full compliance. This can help you avoid fines, delays, and legal issues. Thirdly, uncertainty. Sometimes, the specific requirements of a situation may not be clear. This could be due to unusual circumstances, conflicting information, or simply a lack of expertise. In these cases, it's best to err on the side of caution and take the more conservative approach. Fourthly, long-term benefits. While it may be tempting to cut corners or take shortcuts to save time and money, erring on the side of caution can often lead to long-term benefits. A well-designed and properly installed electrical system will be more reliable, efficient, and safe, which can save you money in the long run. Fifthly, professional reputation. As an electrical professional, your reputation is one of your most valuable assets. By consistently erring on the side of caution, you demonstrate a commitment to safety and quality, which can enhance your reputation and attract more clients. Sixthly, examples in electrical work. This could mean using a larger wire size than required, providing more working space around equipment, or installing additional safety devices. Seventhly, consulting with experts. If you're unsure about the best course of action, don't hesitate to consult with experienced electrical professionals, engineers, or code officials. They can provide valuable guidance and help you make informed decisions. Eighthly, documentation. Always document your decisions and the rationale behind them. This can be helpful if you ever need to justify your work to inspectors, clients, or other stakeholders. Ninthly, risk assessment. Before making any decisions, take the time to assess the potential risks and consequences. This will help you determine the appropriate level of caution. Tenthly, continuous learning. Stay up to date on the latest codes, regulations, and best practices. This will help you make more informed decisions and reduce the need to err on the side of caution. 11thly, ethical considerations. As an electrical professional, you have an ethical responsibility to protect the safety of the public. Erring on the side of caution is a way to uphold this responsibility. 12thly, local amendments. Always be aware of local amendments to the NEC or other codes. These amendments may be more stringent than the national codes, so it's important to comply with them.